Specifications 101, the basic principles. The essence of specifications is really a description of going from macro to micro, the high level to the highly detailed level, from high altitude to granular, from design to detail, from what it is to what it's made of. Let's take a journey on that concept. We're going to go to this website right now. Just travel with me. This is the galaxies as we're getting closer and closer and closer to Earth. Every time going another zero closer in terms of order of magnitude. Finally at our scale. As we dive into the cellular structure of the leaf, going from the farthest reaches of outer space, isn't it funny that the inner reaches of the leaf look awfully close to outer space? Another way to think about them is that specification is a call to specific action. In other words, it's that which you must do. You must take specific action in order to execute this project correctly. Specifications are inherent with the concept of risk. An architect-engineer uses specifications to protect their risk, to make sure that their design is executed the way they intend. The specifications describe the project requirements and also is a determinant of the project quality expected by the architect. The products that go into the building, however, are really created by manufacturers that use specifications to specifically describe those products, what the requirements of those products are, and also to use specifications to support their marketing. Now, you, as a contractor, are right in the middle. You have to ask your question, does the architect-engineer's intention with the specifications align with the manufacturer's requirements of that product? You're not going to be asked to sort of dissect this, but you're going to run into the intersection of what the manufacturer expects to deliver and what architect expects to receive, and you're going to be caught in the middle. And therein lies the risks, because I can tell you right away that oftentimes the specifications from the manufacturer do not align with that which the architect requires, and you will find yourself in the position of having to solve that problem. There are 4 ways to specify, and these are important to remember: prescriptive, performance, a reference standard, and proprietary. Going into a little bit more detail, prescriptive is exactly as it sounds, a prescription. It specifies the materials and the methods without products identified. It is the means to an end. In other words, it specifies the materials and the methods used to produce the product, the means to an end. Performance, on the other hand, is the end, not the means. It specifies the results to be achieved and the criteria for measuring the results, but does not specify the materials and methods, nor the products. Reference standard is probably the simplest of all because it specifies a product or a process by an established and usually a published standard, such as a MnDOT specification, which we'll describe in a moment. And a proprietary specification is brand specifics. Brand X. A proprietary specification is brand specific. In other words, Acme Product X. A closed proprietary specification basically specifies a product without any substitutions. In other words, thou shalt use Acme brand X. An open proprietary specification, however, permits a substitution by simply appending the clause Acme brand X or equal, where the equal, determining that equality, is the burden of proof that rests with you as the contractor to demonstrate that your suggested product is equivalent to Acme brand X, and that is not so easy to achieve. The level of detail between performance and prescriptive or descriptive specifications is really quite clear, and these are some really good examples that you should study. For example, a performance specification for a roof is simply going to say it must meet the UL Class A roof assembly with a flame spread of 25 or less. It must have insulation with a thermal resistance rating of R14 and a membrane attached in a manner to obtain an factory mutual I-90 uplift wind rating. In other words, it's not specifying a product, a type of material, anything. It just says, in the end, when this roof is done, it shall meet these criteria. And of course, what's not listed there is it shall be watertight. Whereas the descriptive specification is going to say, install me a roof 48 mils thick of PVC mechanically attached as a membrane over 2 inches thick of polyisocyanurate roof insulation. That's fairly specific. It doesn't identify a brand, however, but it does say exactly what you're supposed to provide in terms of thickness. So you can imagine performance and descriptive or prescriptive all over the specifications for all products incorporated within the project. It is really important for you to understand the difference between performance and prescriptive because it really has different requirements for you as a contractor. Performance means that you get to choose. Descriptive or prescriptive means that you have to adhere to the specifications exactly as they are written. The types of specification are really 4. The preliminary project description, which has very little text, is very broad and is most likely to accompany a schematic or early design development pricing set. Then we go to an outline specification, which still broadly defines the project, but breaks down the project into a more of a broad scope specification level of detail. It's a highly generalized specification and usually accompanies a design development set. Has a little bit more text than a narrative. The short form specification is really suitable for contract documents, but the sections are essentially punctuated and usually are used for small and simple projects, where a long form specification, that which has the greatest level of specification detail, perhaps even into the specification of a screw, the long form specification is really the one that is used for larger projects that has the greatest amount of detail and a lot of text for you to wade through. Reviewing the types of specifications and some examples, let's go through what a concrete slab would look like going from this macro to micro, starting with the preliminary project description. Imagine this accompanying your proposal. The project will have a concrete floor slab. Now, accompanying your design proposal, perhaps, a 5-inch reinforced concrete slab, machine troweled smooth with curing compound. Again, a little bit more detail, but not all the detail. The short form specification, which you might use for your small project, which will say 5-inch concrete slab, 3,000 psi concrete at 28 days with so many pounds of fiber mesh reinforcing per cubic yard, no air entrainment or colorant, machine troweled flat with less than 1/8 inch deviation and 10 feet in any direction, curing compound, and you got the message. And then finally, the long form specification, 5 pages of which I shall not recite at this particular time, but will have detailed description of every component to the concrete, the gravel, the sand, the aggregate, the cement, everything you can possibly imagine in all of its gory detail. to expand on this prescriptive versus performance criteria, the prescriptive specification, that is, to prescribe as to its specific attributes, will say the concrete will be proportioned with so-and-so percentage of sand of a certain grade, such and such a percentage of gravel at a certain grade, such and such a percentage of cement, so much water, certain types of admixtures, and a percent of air entrainment, so on and so forth, to get exactly the mix that was intended for the design. Versus the performance specification, which will simply say 3000 psi, air entrained concrete, tested in accordance with ASTM standard whatever, suitable for exterior applications. Both of these have their place within a project. Both will appear on a project. You have to understand that prescriptive means you follow it to the letter. Performance means you have latitude as to how you achieve that particular result. So what about these reference standards? Well, the reason I bring up reference standards is they're particularly popular with organizations such as MnDOT that do a lot of construction, and they usually publish standards. For example, a MnDOT B612 specification is for curb and gutter 6 inches high by 12 inches deep. It is identified in a manual published by MnDOT of all of their standard details and only needs to be identified on the drawings simply as B612 curb and gutter. You as a contractor installing the curb and gutter would simply need to look at the MnDOT reference manual to know exactly what it is you have to produce. Reference standards, again, generally work best with commodity-type products like curb and gutter, something that's very simple and repetitive and easy to use. Now, in the case of U of M, we'll talk about that here in just a moment, but the University of Minnesota, because they do so much building, also wants to apply reference standards to standardize their design, as well as to have a uniformity of application so as to simplify their maintenance across the campus and across all buildings. So this is a little bit more detail about what the U of M would do with a reference standard. Think about it this way. On the top of this chart, facility managers define the protocols that will be built into the standards. And it's really a living document. It's constantly changing. So they establish the standards. They then, by contract to the A&E team, say, thou shalt design this building with these standards. The A&E team interprets those standards into the project specifications, which the contractor then uses to price and build the project. The contractor then will provide feedback to the facility management team when requested on exactly how those particular specifications work, perform, and will be maintained. That's how it is a living document. It relies on the industry boots-on-the-ground experience to inform decisions that will have an impact not only on cost, but lifetime of the building and its maintenance. It is critically important for organizations such as the University of Minnesota to have these sorts of reference standard specifications for all that they do. So it's important to understand the level of detail between outline, short form, and full specifications. Outline specifications and the preliminary project descriptions that we talked about earlier are not contract documents. Those are specifications that will accompany typically a proposal. A proposal is not a contract, and these are generally less detailed, mostly because you don't have a contract yet. The contract documents, however, will have drawing notes, which is a form of specification, and it may have either short form or long form, full-length specifications that are generally detailed appropriate to the type and requirements of the project. Short form and long form specifications are contract documents. So when we look at the risk associated with the specifications, it's important to understand that a short form specification and a long form specification as a technical spec offer more protection than an outline specification that simply describes an object, if you will, but doesn't necessarily provide the detail, which really gives less protection. So again, there is less protection with a proposal and more protection with a contract. But the question of who owns how much of that risk is always in play. For example, a short form specification might be slightly deficient in one aspect of the specification that may cause a dispute on the project. By the same token, an outline specification, by virtue of its simplicity, has a high level of risk for the owner and a fairly low level of risk for the contractor because there's a lot of wiggle room in a set of outline specifications. It really relies more on trust, to be certain. The CSI-PRM identifies this project agreement chart. The specifications are a part of the project agreements. They're part of the project documents, which consists of the contract drawings, the specifications, the conditions of the contract, and the contracting forms. The documents, as I said, consist of the procurement documents, which are the solicitations and the instructions, and these are usually bound into the specifications. The contracting requirements, which are also bound into the specifications, which include a form of agreement, any bonding requirements, and the conditions of the contract, such as the AIA A201 and the supplementary conditions, are included therein. And then the specifications themselves, going from Division 1, General Requirements, to Divisions 2 through 49, which is what I call the guts of the specifications, the stuff you really have to pay attention to. And, of course, the drawings. So when we think about the procurement requirements as a part of the specifications, this is going to include the types of bids or proposals that will be accepted, what the bidder qualification requirements are, what are the requirements for procuring for the bids, what are the instructions for procurement, instructions to bid, what available information is there for the contractor to bid, what are the procurement forms and the supplements that the contractor must consider when submitting the bid, and finally, what are the procurement proposals? What exactly is the owner asking for? The supplementary conditions usually expand upon the AIA A201 general conditions of the contract, specific to the requirements of the owner. In other words, this is a higher level of detail than you would see in the AIA A201 general conditions of the contract. These supplementary conditions will usually identify very specific insurance requirements for the project, how the progress payments are going to be handled, whether or not you're going to have wage rate requirements, which may be statutory, whether you're going to have any equal employment opportunity requirements, whether you're going to have any liquidated damages in the project and how those are assessed and measured, what are the requirements for retainage and its release, whether there's a tax-exempt status, and any number of other things that the owner will feel are important to provide additional levels of detail than would appear ordinarily in the AIA A201 documents. You have to be very careful of the wording in the supplementary conditions. The wording is intended to build upon and not delete provisions of the general conditions within the specifications. Oftentimes you may find contradictions between the supplementary conditions and the general conditions, and that is something as a contractor you have to be particularly aware of because they could involve cost. When we think about the hierarchy of governance, when you think about the general conditions, again, the AIA A201 general conditions of the contract, if you will, and then you consider Division 1 of the specification, which is called the General Requirements for specifying. And then finally, you have Part 1 of every single specification section, which is labeled General. Well, basically, the general conditions, the AIA A201, is a very broad scope, whereas the Part 1 General of the specification section is highly specific. The general conditions govern Division 1, which governs Part 1. It's a definite hierarchy. When you think about what is actually a specification and what is not a specification, it's important to see that the conditions of the contract and Division 1 are in fact different in this regard. The conditions of the contract, which includes the general conditions, the AIA A201, and the owner's supplementary conditions, are not specifications. Remember that. AIA A201, the general conditions, and the owner's supplementary conditions are not specifications. Those are contracting conditions. Division 1, the general requirements, and the sections of Division 1, that is the Part 1 general in each of the specification sections, are naturally specifications. They are a critical component of the specifications. So you need to understand that difference. So the essence of specs, as I've described throughout this entire lecture, is macro to micro, high altitude to granular, design essence, the overarching design down to the details of how that design is executed, and finally, the what it is and what it's made of. Quite specifically, we're done. Thank you.